Hello everyone and welcome to another episode of Investigation. In today's episode of Investigation, we'll go over 2022 AMC 10B number 21, which also, for the record, is 12B number 20 as well. So this problem states, let p of x be a polynomial with rational coefficients such that when p of x is divided by the polynomial this, the remainder is that. When it's divided by the polynomial that, the remainder is 2x plus 1. There's a unique polynomial, blah, 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 with the least degree of these two properties. What is the sum of the things? Okay, so we know that p of x is equal to x squared plus x plus 1 times some other polynomial q1 of x plus x plus 2. And p of x is also equal to, you guessed it, x squared plus 1 q2 of x plus 2x plus 1. So we want the least degree possible, right? So we want p to have the least degree. Then we want these two, q1, q2, well, they will have the same degree because this degree multiplied by this 2 or added to 2 is going to be the overall degree. Unless, well, q is 0, I guess, then the p of x will be linear. So if q of x equal to 0, then we can't have it. If it's equal to 0, then we would have that this will be equal to x plus 2, this equal to 2x plus 1. Obviously, that is not the same polynomial, so we can't have that. If we have q1, q2 of the same constant function, so like if we have q1 of x equals a constant, q2 of x equal to another constant, then we know these two constants have to be the same because they are multiplied by this x squared term. And the only possible way to get the x squared term is multiplying that by q1 of x. So that is the same. So p of x, if we expand the first one, we'll get cx squared plus cx plus c plus x plus 2. And p of x is also equal to cx squared plus c plus 2x plus 1. So the x terms must be equal, so c plus 1 is equal to 2, but then also the constant term has to be equal, c plus 2 equals c plus 1, which cannot be achieved. So q is not a constant function either. So next, we are going to try q is maybe linear. Then if q is linear, then let's say q1 of x is equal to ax plus b, and q2 of x is equal to, note that the leading coefficient is going to be the same because this x plus 2 is not going to be like high power enough to affect the leading coefficient. So this x squared multiplied by this a over here would get us the cubic term, the only cubic term. So this x squared multiplied by this coefficient right here would also give us the cubic term. So this has to have ax plus, let's say, c. Then p of x is equal to x squared plus x plus 1 times ax plus b plus x plus 2. It is also equal to, what we have is x squared plus 1 times ax plus c plus 2x plus 1. On this side, we have ax squared plus ax plus x squared, ax cubed plus ax squared plus ax plus bx squared plus bx plus b plus x plus 2. On this hand side, we have ax cubed, so the cubic terms will actually match up, plus this will be the x squared term, cx squared, the x term, ax, the constant term, c, plus 2x plus 1. Let's put it aligned like this, plus 1. So over here, if we set up the quadratic term, here is a plus b equal to c. If we set up the x term, then we would have a plus b plus 1 equals a plus 2. And if we have the constant term, we use k. I know constant starts with c, but usually we denote it with a k. B plus 2 is equal to c plus 1. We can use the middle equation to get b plus 1 equals 2 or b equals 1. So here we plug it in, we get 3 equals c plus 1 or c equals 2. And here we get a plus b or a plus 1 equals 2 or a equals 1. Therefore, we would have p of x equal to x cubed plus a plus b 2x squared plus a plus b plus 1 3x plus this b plus 2, which is 3. You can check that this polynomial actually do satisfy the condition, and it is the only cubic polynomial that does satisfy the condition. So we want the square of the sum of the squares of the coefficients. So 1 squared plus 2 squared plus 3 squared plus 3 squared. That's 1 plus 4 plus 9 plus 9. Or we can do this first. Or, if you're at this one, you probably don't want to make an arithmetic mistake, but I can trust you to do that properly. If you do that, you get 23, which is our answer choice E. And that will be the answer to this problem. Thank you for watching this episode of Investigation. If you have any questions, whether or not it is related to this question or not, please put them down in the comments section below, and I will try my best to answer all of them. With that being said, that will be it for today, and I hope to catch you in the next video. Goodbye.